On Monday, you worked on the activity, the Desmos activity, that you dealt with pinwheels and polygons. Well, when you set up the pinwheel like this figure here on the left, if we were to trace along the outside of that figure, really what you were creating was a certain type of polygon. This, if I followed just the outside of that figure, would be what's considered a concave polygon. Sometimes I think about concave being a figure where it kind of caves in. Technically, what a concave figure is if I were to draw a diagonal, so say I were to draw a segment from one point, maybe I call this A and I call this B, that diagonal may lay on the outside of the figure itself. If I connected A to a different point, say point C, I might have a diagonal on the inside as well. But if it's concave, you may have diagonals that actually end up being outside of the figure. Versus when you made the polygon, here, this is an example of a convex polygon. And that's because anytime I draw a diagonal, let's see, that diagonal is going to still be on the inside of the figure. Okay, the book, I think, called it, instead of concave, maybe non-convex, but it's the technical term would be a concave figure. In both cases, though, they were created with triangles where all of those triangles fit in the middle, essentially creating 360 degrees. The key to this was, if I'm going to make a convex polygon, not only do those angles have to fit together, in other words, you had to be able to take 360 divided by how many you were dealing with. In this case, you had 1, 2, 3, 4, 5. You had to be able to divide 360 by however many triangles you were working with in order for it to work. In this case, that ended up being 72 degrees for each one. So you had to be able to check that off. But the other thing, in order to make it convex, all these had to fit together, which meant that this segment had to be the same length as this segment, which really means I had to have dealt with isosceles triangles. So if I looked at this one here, I had 72 degrees, but that was in between two sides that were the same. So in order to make a convex polygon, we had to have two things. We had to have a number of triangles that I could divide 360 by, but I also needed to have isosceles triangles. So when you did, toward the end of that activity, they gave you these different triangles, and you had to decide, okay, which ones would actually make that convex polygon. Well, to make that decision, the first thing I'd look for is, do I have my isosceles triangle? So the first one's isosceles, the second one's not, so I know that's not going to make a polygon or a convex polygon. This one is, so maybe it would work. 70 and 70, it is, so maybe it works. This one is not, so no, it won't make the convex one. The last one is isosceles. So the next thing I would check is, okay, well, the angle they give me, can I divide that by 360? Well, the first one, if I take 360 divided by 72, it works out, and it gives me 19.5. So this means that this one was going to be a convex polygon. And in fact, since there's 5 sides, we know it's going to be a pentagon. The next one we already knew did not work as far as the convex polygon. The one with 20 degrees, if I take 30 divided by 20, we get 18. Now, you could probably look up the name for that, but we're just going to call that an 18-gon. Basically, anything over 10, we'll just name it like an 11-gon or a 14-gon or something like that. This third one, or the fourth one, I should say, I've got 70 and 70, so I know I'm left with 40 degrees here. So if I take 360 divided by that 40, I get 9. So this was a nonagon. So that would be convex. This one we already said was no, and then the last one I'm going to check. It's isosceles, but if I take 360 divided by 38, I get 9.4. So that tells me this one will not fit together as well, it will not be a convex one. Now, it doesn't mean the other ones couldn't fit together. For instance, this one with 120, well, I can take 360, I can divide it by 120, and that comes out nice and neat. However, since it wasn't isosceles, that means that I'm going to have some overlap. I'm going to have some of the pieces that hang out over the edge. Okay, so if I want to make sure it's convex, I have to have both those two things. Got to have that angle in the middle that I can divide by 360, and I've got to have an isosceles triangle. Well, what I'm going to have you try today is kind of the next step to this. You're going to do a couple problems from chapter 8 here to begin with. The first one is problem number 13. So this is from chapter 8 now. But what you're asked to do on this one is I want to know what would be the total sum of the interior angles in this 1, 2, 3, 4, 5-sided figure. So we have this pentagon. Not only is it a pentagon, it's a regular pentagon. Or in other words, all the sides, all the angles are the same. The instructions say to come up with as many ways as you can. I'd like you to see if you can find 2 different ways to find that sum. As a hint, if you've done it correctly, your sum of all those angles put together should be 540 degrees. But I'm more concerned with that you can come up with a method or a way to actually come up with that 540 degrees. Okay, so I want you to spend some time on number 13 doing that. Once you finish number 13, then I want you to try number 14. Part of number 14 has this table. And notice what the table gives you. It talks about the number of sides of a polygon, and then it talks about the sum of the interior angles of a polygon. And they gave us the first one, the one we've already dealt with. When we have 3 sides, or in other words, we have a triangle, we know the sum of the interior angles is 180 degrees. So what you're going to do is you're going to try to see, okay, well, what are the totals for these other polygons when they have increasing sides? But you really should try to see if the method used on 13 will carry over to the ones that you try when we have different side lengths here. All right, so for right now, I want you to try in chapter 8, number 13 and number 14. Put some thought into your answers. And then here in a little bit, after you've gone through that, you've thought about that, then you can come back and you can check out my video on maybe some ways that you can approach those 2.